Today we're going to be looking at factoring by grouping, and we're going to start with something that's already factored because we're going to have to factor these a few times to get the end product. So when we are looking at something that's already partially factored, which is what these examples 1 through 4 are, we're going to be looking for a common binomial. And remember, a binomial is something that has two terms. So when factoring a polynomial, look for a common binomial. Factor out the common binomial and write the polynomial as two binomials. So in the end, you're going to have two factors, both binomials. You'll have one factor and the other factor, and that's going to be our end game. We're going to start though just by recognizing the common binomial. So looking at these first 4 examples, we're looking for what is our common binomial. So you look here, you can see there's a binomial that's the same. So what's the common binomial in this problem? Y plus 4. Looking at the second problem, I'm looking for the binomial that I see that's the same. So the two terms, it's exactly the same. And in this one, it's x minus 4. The third one, I can see right there, the parentheses are kind of our hint. That's where it is. And in this one, we have a plus b as our common binomial. And then this last one, we have x plus y and y plus x. But remember, with addition, the order doesn't matter, so that's exactly the same. So our common binomial here is y, or x plus y. All right, so all we were doing with those 4 problems was just seeing what the common binomial was. Now we're actually going to do the factoring of that binomial out of the problem. So looking at example 1, I can see my common binomial. It's y plus 4. And I want to factor that out. So my common binomial is y plus 4. So I have to think, if I remove y plus 4 from here, so essentially just like we did with the factoring by GCF, and removing that from that part of the problem, what's left behind? Well, I have an x left. And if I do the same over here, if I'm removing the y plus 4, which means I'm really dividing it by y plus 4, what is left there? A minus 3. So that gives me my 2 binomials. I have y plus 4, because that's what I factored out of both of those. And then I have what's left over, which is x minus 3. Now all of this work right here, you can do in your head, because you can think of, if I removed that y plus 4, what's left? If there's an x there. And if I remove it from the second grouping, there's going to be a negative 3. So let's take a look at number 2. I see my common binomial. That's x minus 4. And I'm going to write that out front because that's what I'm removing. So if I remove that x minus 4, what's left there? X. And if I remove it there, what's left there? Plus 4. So there's my 2 binomials. And that's completely factored. Looking at number 4, there's my common binomial, x plus y. So that's going to go out front because that's what I'm removing. And then what is left behind when I remove it? Well, when I remove there, what do I have? Z. Now here's the tricky one. A lot of us mess up on that second one. Because you say when you remove it, there's nothing. But that's not true. If I'm dividing by x plus y here, because that's what I'm really doing when I'm removing it, what is x plus y divided by x plus y? It's 1. Another good idea might be if you do have a group that doesn't have something with it, like this had the z with it, maybe to put a 1 in there so you don't forget about that. All right, looking at number 5, I see my common binomial right there. There's nothing in front of this first group, so I'm going to put a 1 there so don't forget that there is a 1 there. There's one of them. So I'm taking out an a plus b. And when I do that, when I remove a plus b, what's left? 1 is, those problems were all partially factored for you. So we have to move to where we actually have a problem where we have to do the whole thing. So here are the steps when we're factoring by grouping. You want to form small groups of 2 terms with a GCF. So if I'm looking at this problem, I look at that group. They have a GCF of X. Then I'm going to look at the second group. They have a GCF of 3. Sometimes I have to move things around. Sometimes it works out well. So that's my first step, is just determining my GCF. Second step is to factor out the GCF in each group. So this first group, I'm factoring out an X. When I remove an X, what's left? So I am taking each one of these and dividing them by X. What's left? Y plus 8. Now in my second group, I'm factoring out a 3 because that's my GCF. So this is going to be plus 3. And what's left when I factor that out? Y plus 8. So now I'm adding just a step. If you look at step 2, that's how the problems looked on the front of the notes. Now we're doing that part to get there. Now I'm just going to do what we did on the front. I'm going to factor out that common binomial and then write my answer as 2 factors. So for this first group, I have y plus 8, and for that second group, I have y plus 8. So that's my common binomial. Now, if I get to this point and I don't have a common binomial, I need to start over again because I made a mistake somewhere or I grouped things together that don't end up producing a common binomial. And then I look at what's left when I remove those. And when I remove those, I have x plus 3. So that's my second binomial, x plus 3. I'm going to work a couple examples together. Looking at example 1, I'm going to group those 2 because they have a GCF of A. And then I'm going to group these 2 because they have a GCF of B. Sometimes, like I said, you have to move them around. Sometimes they just work out. That first group had a GCF of A, and when I remove A from each term, what's left? R plus S. That second group had a GCF of B, so plus B, and when I remove B, what's left? R plus S. Now you should be able to see here that I have a common binomial that's R plus S. R plus S gets factored out. When I remove that from each of those groups, what's left? A plus B. There are my factors. All right, example 2. First group, I have a GCF of X. Second group, oh, I gotta be careful here. I do have a GCF, but it's of a negative y. Remember when we did factoring by GCF, we said if everything was negative, then a negative is a common factor because everybody has it. That's the case here. These are both negative terms. There's a negative and a negative. So I need to pull out a negative because that's common between them. So now I'm going to factor out my GCF, factor out the X from that first group. And when I factor out an X, so think about it, I'm dividing by X to both of those, I get X plus Y. That second group, I'm factoring out a negative Y. Negative Y. So what's left when I remove a negative Y or when I divide by a negative Y? X plus Y. Now I can see I had a common binomial. If I hadn't factored out a negative here, I wouldn't have had the same thing in my parentheses. So I would have had to go back and rework the problem. So now I can rewrite this as x plus y, because that's my common binomial. And then what's left is x minus y. All right, let's take a look at example 3. In example 3, the terms that are right next to each other do not have common binomial, or do not have a GCF. So I have to move some things around. So I'm actually going to move the 7 back here, negative 7, and then negative a up that way. So I'm going to rewrite that problem. AB minus a plus 7b minus 7. So a couple of things I did here. I grouped these together because they have a GCF of a. Then I grouped these together because they have a GCF of 7. And there's different ways you could have grouped it. Some of you might say, can I put AB with 7B? You could, because then they have a GCF of B. And then the negative A and the negative 7 would have a negative GCF. So there's different ways to do it, but you're still going to get the same answer. Something else I want you to notice that I did. My first term in this one had a B. So I made sure my first term in that group also has a B. That's just going to make sure that, or ensure that my common binomial is going to be the same. So this first group, I'm factoring out an A. And when I do that, what's left? Well, remember that's dividing by A. So that's B minus 1. My second group, I'm factoring out a 7. So I'm dividing by 7. So that leaves B minus 1. Now I can see here I have a common binomial, B minus 1. So now I can write my two factors, B minus 1 with my common binomial. And what's left? A plus 7. And that's it. And in fact, the nice thing about this is if you multiply this out, if you went ahead and multiplied this back out, you would get that same problem. So that's always a way to double check to make sure you did it correctly. All right, looking at number 4, you can see I have some things that do not have GCFs together, so I've got to move some stuff around. A couple different options here, just depends on how you want to do it. I am going to put negative 2y plus 10 together. And then I'm going to put negative xy plus 5x together. Why? You might say, why did you do that? Well, I looked at these two and said they would have a GCF of 2. Then I looked at these two and said they would have a GCF of x. And that's why. Now, you could have put the 10 and with the 5x, because then they would have had a GCF of 5. We could have put the negative 2y with the negative xy, and they would have had a GCF of a negative y. You can do it a variety of different ways. There's options here. It's just whatever you see. So looking at my first group, I'm factoring out a 2. And what's left? Negative y plus 5. My second group, I'm factoring out an x, so plus x. And what's left? Negative y plus 5. Now I see I have a common binomial right here. So negative y plus 5 is one binomial. And my other one is 2 plus x. There we go. And again, if you did it different, if you grouped differently, you might have slightly different binomials, but they're still essentially the same. All right, we have a couple you-dos to work on.